Hey guys, what's up? Avi here, and welcome back to our LangChain series. In this video, we're talking about one of the coolest concepts that LangChain has to offer, which is called agents. The agent interface provides the flexibility for applications to chain a series of calls and other tools based on a user input to get to an answer. An agent has access to a suite of tools and determines step by step which one to use depending on what the user prompted. There are two types of agents: action agents and plan and execute agents. Action agents, at each time step, decide on the next action using all of the output that's been generated so far. Plan and execute agents, on the other hand, decide the full sequence of actions up front and then execute them all without updating the plan. So let's go over kind of a high-level example to get a better idea of what agents can do. Let's say that my prompt or my question here is, when was the third president of the United States born? What is that year raised to the power of 3? If you were to plug this in to a large language model like TextDaVinci 003, you might get the first question right, but I guarantee you the math would be wrong. And especially when it comes to current events, weather data, API data, etc., getting that up-to-date relevant information is very rare, especially when these large language models were trained with data up to 2021, 2022, etc. And they have a wide corpus of data to choose from. That's where these tools come in. Tools are actions an agent can take. There's tools like Wikipedia, tools like Google Search, tools like a weather API. What tools you give an agent depends on what you want the agent to do. For example, in our question of when was the third president of the United States born, that might be answered through Wikipedia. What is that year raised to the power of 3? That might be answered via a call to LLM Math or to Wolfram Alpha. So that is kind of agents in a high-level nutshell. An action agent follows these steps. It receives the user input, decides which tool, if any, to use, calls the tool, records the output, which we call an observation, and then decides the next step to take until it figures out if it can respond directly to the user. Let's dive right into an example. First thing first, we're going to be using Wikipedia as a tool in this video, so let's install it beforehand. You can do this by running the command python3-m pip install Wikipedia in your terminal. After Wikipedia is installed, let's go ahead and print out all the available tool names so we get an idea of what we can use with our agent. I'm going to use Python's prettyprint library to make the output easier to read. I'm going to start by importing the pprint module, import pprint, and then I'll also import the necessary functions from langchain.agents. From langchain.agents, import get_all_tool_names. Now, I'll set up a pretty printer using pp is equal to pprint.prettyprinter, indent equal 4. And then finally, I'm going to print out all the tool names with pp.pprint getAllToolNames. If we run this, we can see that the output shows all the available tools in LangChain. That's quite a few. You can see there's Wikipedia, Google Search, LLM Math, among others. Now that we have an idea of the available tools that we can use with our agent, let's dive into an example with an action agent using Wikipedia and LLM Math. First, let's import the necessary modules. From langchain.llms, import OpenAI. From langchain.agents, import load tools. And from langchain.agents, import initialize agent. Then, we'll set up the language model from OpenAI with a temperature of 0. LLM is equal to OpenAI, temperature equals 0. After that, let's load in the necessary tools. Again, the question that we're trying to answer is when the third president of the United States was born and what's the year raised to the power of 3. So the tools that we're going to use here are going to be Wikipedia and LLM Math. It's important to note that LLM Math actually requires a language model to be passed in, because what LLM Math does is it takes in an input, converts it to Python code, and executes that Python code to return a result. So we can say here tools is equal to load tools, and then in parentheses pass in a list of tools, in this case Wikipedia, LLM Math, and then specify the LLM parameter to be the LLM we just created. Now that we've loaded our tools, we can initialize the agent with these tools. And we can specify our language model and then specify the agent type as zero-shot React description. So we can say here agent is equal to initialize_agent, and then our parameters are tools, LLM, our agent is equal to zero-shot React description, and verbose is equal to true. So this agent that we just passed into initialize agent comes from zero-shot React. Zero-shot react is an agent type, one of several that determines what action to take in what order. With zero-shot, the agent uses the React framework to determine which tool to use based solely on the tool's description. Any number of tools can be provided, and this is the most general purpose action agent that you'll normally see. So now that we've created our agent, let's go ahead and run this agent with a question. Agent.run, when was the third president of the United States born? What is that year raised to the power of 3? By specifying verbose equals true, we can see a detailed response. Let's walk through the output step by step to explain what's happening. So the first thing it does is enter a new agent executor chain. The thought it comes up with is it needs to find out when the third president of the United States was born and then use a calculator to calculate the power of 3. So the first action it takes is Wikipedia. By entering the third president of the United States, it comes across the Thomas Jefferson page, and from there it gets the year 1743. Now that it knows that the year Thomas Jefferson was born is 1743, it can use the calculator action, which is LLM math, and raise that number to the power of 3. When we compare the result that it outputs with the Google search of 1743 to the power of 3, we can see that that is indeed the correct answer. And that's it. Action agents, or agents in general, in LangChain are very powerful concepts. You can imagine a wide suite of tools, not just Wikipedia or LLM math, but Google search results, weather data, etc. And the more tools you incorporate and the more complicated prompts or questions you want answered, this is where the power of LLMs and tools can come in. So that's agents in a nutshell. Thanks so much for listening, and I'll see you in the next video.